Alright guys, welcome back. We're going to continue on looking at quadrilaterals. And so far, up until last week, we really covered parallelograms. What we're going to cover this week is some more different types of parallelograms, so special parallelograms. Like in this lesson, we're going to look at properties of rectangles, rhombuses, and squares. And then towards the end of the week, we're going to take a look at some non-parallelogram quadrilaterals, so your kites and your trapezoids. So the main thing here, remember we kind of talked about this in class a little bit. We did a kind of an if-then, right? 9.1 was if it's a parallelogram, then what do we know? And then 9.2 we switched it. We did the converse. And we said, all right, what does it take to know, if something, then it's a parallelogram. What do I need to know to make this a parallelogram? So 9.3, we're going back to like our original statement. If it's a rectangle, what do we know? If it's a rhombus, what do we know? If it's a square, what do we know? All right, so that's kind of where we're starting here. So we're going to start with rectangles here. So a rectangle is a parallelogram with all equal angles. So if we're taking a look at theorems of rectangles, so again, the big idea with rectangles is I took a parallelogram, I made all the angles equal. And there's one big theorem out of this that you need to know. And that's this one here. This is the second one. This one right there. Okay? If a parallelogram is a rectangle, then what do we know? Its diagonals are congruent. Now they have, if you look in the textbook section, I've blanked it out here, there's like a long, maybe 12-step proof about how to get there. But I think this picture really covers it pretty well. So I have a rectangle, and I happen to know that it's also a parallelogram. So I know that this side AD is the same size as this side BC, because opposite sides are congruent. And then I also happen to know this side DC is reflexive. And it's reflexive because it's actually shared right here. You can see right there, that side DC, we basically took the two triangles and we pulled them apart to take a look at them. Now, because it's a rectangle, I also happen to know that these angles are right angles. If you take a look at angle D and angle C. So then I know the triangles are congruent, so I know ADC is congruent to BCD, and if the triangles are congruent, then by CPCTC, I know that these hypotenuses are also congruent. If the hypotenuses are congruent, well, that's the diagonals of a rectangle. So there's like a rough version of that proof of what it might look like. And let's see how that plays out in some actual problems here. So if we kind of scroll down through this, all right, so take a look at number 5. They say, okay, we know, we're just going to talk about how we might solve some of these. So AD is 7.5, and DC is 10. Okay, solve for DB. Well, what do I know about this triangle ADC? Okay, well, I happen to know that ADC, okay, I'm just highlighting it so we can see that right there. Well, that's a right triangle, right? I've got a right angle in there. ADC is a right triangle, so I could actually use Pythagorean theorem here. So if I wanted to solve for DB, and remember, DB is the same size as AC, what I would do is I would set this up with Pythagorean theorem. So this would be one type of problem that you might see from this. Really, it's not about memorizing types of problems, it's about understanding how these different truths, how these different theorems play together. So I know diagonals are congruent, so if I get a diagonal problem, I might set them equal to each other. So as I solve this out, I get 7.5 squared plus 10 squared, and I could solve for c squared, and that would be AC, and then that would also be the same as DB. So that would be a way that we might solve a rectangle property. Now, rectangles people tend to have a pretty easy time with. It is really important, though, that you do know these theorems, okay? If you don't know your parallelogram properties, if you don't know that opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and diagonals bisect each other, all right, you're going to have a hard time because we're going to stack more theorems on top. So I would really encourage you to memorize those parallelogram properties. It honestly would probably only take maybe 10 minutes 2 nights in a row. If you sit down for 10 minutes, turn off the cell phone, turn off the TV, turn off everything, and you just go over, review them, on flashcards, whatever, close your eyes, try to remember the 4 properties. In 2 nights, you could probably have the parallelograms, probably less than that, but if you wanted to do it a couple nights in a row to make sure you have it. Okay, because we're going to add more, and if you know your properties, it's going to make the test really easy. If you don't know your properties, it's going to get very confusing because we're going to add a bunch on here. So in addition to all the parallelogram properties, we know the diagonals are congruent for a rectangle. That is not necessarily true for a parallelogram. All right, so that is our rectangle properties. Now we're going to look at the rhombus properties. Now remember, okay, I'm just going to kind of draw the chart out here. So our parallelograms, if we were thinking about our family tree, there's our parallelogram. It's not a great parallelogram. Has 2 branches. One branch has equal angles. Equal angles make rectangles. The other branch has equal sides. Let me make this a little more clear. And equal sides gets you a rhombus. So in this case, equal sides, but not necessarily equal angles, is another type of parallelogram. Okay? And we call that a rhombus. Now, a rhombus has 2 particular properties that we need to know, and this is the one that people have the hardest time with. Okay? If a parallelogram is a rhombus, 2 things. One, the diagonals are perpendicular. Remember, the word perpendicular means it makes 90 degrees. The second property is that if a parallelogram is a rhombus, then each diagonal bisects the pair of opposite angles. Now that sounds like a lot, and it kind of is a little bit. So let me kind of walk you through why this is the case, and then we'll talk about what that means for solving problems. So let's take this blank space, and again, there's a proof here. We're not going to do the formal proof. I'm going to make that picture just a little bit larger. Okay, so I've got some sort of rhombus shape here. Okay, just imagine that looks a little better than it does. Tell you what, I'll give it one more go. If I can't get it better, then we're just going to have to deal with it. Woof. All right, good enough. All right, so say I've got a rhombus here, and I know rhombuses have equal sides, right? Let's think about why these diagonals are perpendicular and why they bisect the angles. So let's start with the bisecting of the angles. If I draw this diagonal, why does this have to bisect the 2 angles? And we'll call this A, B, C, and D. So why does this diagonal have to bisect angle B and angle D? Well, the reason is look at the triangles on the left and right side. The left triangle is an isosceles triangle, and so is the right triangle. And we know they're also the same size by SSS, right? I've got a reflexive side, I've got 2 given sides, so that means these are congruent triangles. I also happen to know that if they're congruent triangles, then these angles need to match up with each other. Okay, so these have to match up with each other, so I've got 2 on the bottom, 1 on the top. But also, I know it's an isosceles triangle. What do I know about isosceles triangles? I know the base angles of an isosceles triangle are congruent, so I can actually then just say no. Not only are they congruent to each other, across the diagonal, but also within the same triangle. So that's why our diagonals bisect the angles. And if I drew a second diagonal here, okay, I'd find the same thing. Okay, and I'll mark these differently because they're not the same size as the ones at B and D. The ones at A and C are only 1 mark. Now, that leads us to our second proof. Why do the diagonals have to be perpendicular? Well, they have to be perpendicular because I know all these angles in the middle, we'll call this point E. All these angles at point E have to be the same size. All right, but I also know that they add up to 360 because it takes a full circle. So what angle added up 4 times gets us to 360? Well, it's 90s. The only way that these triangles could all be congruent is that these are 90 degrees. So this is kind of a rough talk through how a proof might go. Now, it would take a lot of steps to get there in the proof, which is why we're not doing it. But I want you to see that even the theorems that we're getting now, we could write proofs to get us there. So that's all well and good. What does that lead to for actual problems? What does it look like when I run into a rhombus problem? Well, here's an example of a rhombus problem. So the first one, they ask for the length of xy. And we're not going to walk through it, we're just going to talk about the setup. So I know xy is this length down here. I also know all the sides are equal. So they've given me two sides. They've given me VW and WX, and I know the sides are equal, and that informs my algebra. I don't just set up algebra the way I want to. I set it up based off of what I know. What do I know here? I know sides are equal, so I'm going to set them equal. I'm going to go 6m minus 12 is equal to 4m plus 4. All right, so I would solve that for m. Notice they're asking for a length, so I'm going to plug that m back into either one, and that will give me the length for xw. All right, find angle YVW. So notice YVW is this guy right here. We're not going to get the whole way there. What I really want you to focus on is this first step. So notice there's not really any angles given to us here. So what I need to do is I need to go back to my diagonals being perpendicular. Well, if they're perpendicular, that means this guy right here is 90 degrees, right? So to start this problem, what I would do is I would set 90 equal to 3n squared minus 75, or 0.75. All right, now notice a couple things here, guys. If you feel like that just came out of nowhere, go back to your properties. And a lot of this stuff, when we start mixing them up, when it's not just one, parallelograms or just rhombuses or just rectangles, it's going to start feeling confusing if we don't know our properties. But if we know our properties, they're going to guide us to how to set up the algebra. In this case, I would solve for n, and then I would plug n back into this one up here. Let's see if I can get rid of that guy. Okay, I plug it in for 9 n plus 4, and then I would double it to solve for the angle. So that's how I would solve for it. But I want to show you how you get off the ground on a problem like that. We remember that these are 90, so I'd set this equal to 90. All right, so we've talked about rectangles, rhombuses. So remember, in our chart here, so we've got a parallelogram, and if I have equal angles, I get a rectangle. And if I have equal sides, I get a rhombus, okay, with all equal sides. Now, if a rectangle with equal angles and a rhombus get together, we end up with, that is a terrible square. We end up with a square, okay? So we're going to talk about our square properties here. So the square is the combination between a rhombus and a rectangle. Now, the nice thing about a square is that there is no new problems, or there's no new theorems with a square. It's just a compilation of your rhombus rules, your rectangle rules, your parallelograms. It has all the rules. No new ones, but just all of the rules. Okay, now an easy way to think about this, or a way to think about this, is kind of like this Venn diagram here. This does kind of a good job of showing you. So within quadrilaterals, in the parallelogram family, you have rectangles and rhombuses. Now sometimes there's an overlap between rectangle and rhombuses, and where they overlap is the square, but there's nothing new about the square. It's just a combination of these properties. So that gives you like a rough overview. I know this is a long video. You're just going to have to bear with me. There's a lot to cover here. Let's look at one or two problems here that have to do with rectangles and rhombuses as far as solving. So let's go back through all this. So let's look at, here's another way we could think about this too. Okay, so quadrilaterals, we're in the two pairs of parallel lines family. So parallelogram, rhombus, rectangle, and together is square. If you only have one set of parallel lines, you get this trapezoid. The trapezoid shape we'll look at later, and no parallel lines, we get the kite. All right. So let's take a look at one or two problems here dealing with rhombuses. So in this case, we want to solve for the missing angles. Now, because rhombuses are parallelograms, we happen to know, that is not what I wanted to do. We happen to know that opposite angles are congruent. So this guy right here would be 93, right? And then I need to solve for these missing angles down here. So there's really two ways to think about it. The way I like to think about it is just thinking about this as an isosceles triangle, okay? If I think about this whole thing as isosceles, I'm just going to do 180 minus 93, and I get 87. And I'll do 87 divided by 2, I get 43.5. All right, so this is 43.5. and 43.5. Okay, and then if those are 43.5, then these are also 43.5. So I wanted to show you something like that. Okay, the other way to think about it would be instead thinking about this angle 1 and angle 2 as being a whole angle together, subtracting from 180 because it's a parallelogram, and then dividing it by 2. But those are the exact same mathematical steps as before. All right, let's look at 2 more problems, one with rhombuses, one with rectangles. Now, what about a case like this? Okay, I've got a rhombus here. I've got some missing angles, 2, 6, 8, and 10. I'm not going to ask you to solve all the angles. So the first thing I would start with rhombuses is always start with 90 degrees, okay? I know all these guys are 90 degrees. So angle 2, that's 90. I also happen to know down here, that's a 90-degree angle. So I could solve for angle 6 pretty easily, right? 180 minus 90, obviously is 90, minus 38, and I get 52 here. So I have 52 for 6, 52 for 10, all right? And then I could also put these 52s up here, right? 52 and 52. But wait a second, this triangle right here, that's the same as this triangle. It's the same as all the other triangles. So if that's 52, this guy's going to be 38. That's coming from down here. So I've got 38, 38, 38, 38. So you actually only end up with really 3 different angles when you've got both your diagonals and rhombuses. So it actually makes it a little bit easier as long as you remember to add the 90. And then let's look at rectangles. So look, guys, with rectangles, your diagonals aren't necessarily perpendicular. So if they are, then it's a square, okay? But in this case, they're clearly not perpendicular. So we've got to solve for some missing angles. So I've got 150 at the bottom, so this would be 150 up here because they're vertical. And then this over here would be 30 because they're supplementary, they're on the same line. All right? Now, I don't know why that says 83. I think I was supposed to be angle 3. I'm not sure where the 8 came from. All right, so here's angle 3 up here. So I've got 150. Now, once again, I know that the diagonals bisect each other because it's a parallelogram, and I know they're congruent to each other. So I know actually all of these diagonals are cut in half, and they're equal to each other. So actually all the pieces are equal to each other. And what do we end up with here at the top? Another isosceles triangle. I end up with an isosceles triangle with the diagonals instead of the sides. And so once again, all I'm going to do is 180 minus 150. I get 30. I'm going to divide 30 by 2 because I've got to get 180 degrees in my triangle, and I get 15 and 15. Okay? And then I could also solve for 5 because I know that this is 90 together, or I could subtract from 180 from 30. Okay, and that'd be 150 divided by 2. Either way, 75, 75. These two 4 and 5 should add up to 90 degrees, and they do. So those are some angles in rectangles. I want to show you some examples just so we see how all this works. So I know this is a long video. There's a lot to cover with it. We're going to continue looking at parallelograms, but this gives you the theorems that we should know, and then some practical application of those theorems.